everybody. I am Stephen Holinati. I am one of the solution architects here at SailPoint, and I'm here to talk to you today about an interesting use case for using web service connector rules to streamline and accommodate what I like to call interesting sources. So what is an actual interesting API? So for me, an interesting API is something with very odd data input. It can take a long time to process. If you have to make 20,000, 30,000 API calls, that's time, that's money, that's things you don't need. A lot of APIs throttle you. If you try and send more than 10 requests a second or 1,000 requests a minute, they can shut you down with the very beautiful 429 try again later. And for a lot of them, you don't get all the information you need at the right layer. You have to call API after API after API after API. So as an example of this, what you see on screen here is multiple endpoints with paginated users where we have to then get reference IDs off the user response in the top left. After the reference ID, we have to call /job/1 to find out what your job title is. We have a bunch of IDs that aren't really useful to us at that main level. And so we had a couple options for dealing with this, one of which is we can try and make those very complex hybrid entitlement types. The user has job ID 1, which is actually a job, not a string, where that then has a title. The problem with that one is if you try and map that up to an identity attribute, now it's only going to hold the number, and no one needs to know what job number 1 is. We can do this with a transform, with a lookup, and we'll touch on that later. Those are unwieldy, they're hard to maintain, they can get rather complicated. We can do this with nested API calls, but at scale, you have 10,000 users and you need 7 endpoints. That's 70,000 plus API calls. And what the main part of my presentation today is on, we can do this with web service rules. So we can do this by calling APIs, and what we'll find out later, we can do this with storing those values and using them later on in the day. So let's quickly run through a few of those options. So transforms, they're easy to use, they're great, but they are hard to maintain. So what we have here is essentially for lookups. We can build, 1 is engineer, 2 is manager, 3 is CEO. We can build a mapping, but how do you maintain that? How do you update that? Do you need a calendar reminder every month? Do you only change it when something goes wrong? Run a scheduled search? And what if HR changes something and doesn't tell you? Because unfortunately, HR does not always tell IT and IAM and everybody else what has changed. So in the example you see in the bottom left here, this is a functional transform that will give you values. And as you can see here, I have as the default value. So let's look into that a little further here. So to me, that means we can run a scheduled search. Who's set to that's the value we have to fix for those values. We could even do this in a workflow. We can trigger your attribute's value has become if you have our workflows feature. You can get an email, let's say, to update that list. That doesn't work very well. As I mentioned, we can do this with complex entitlements, which really means, again, we look up your job code. That's an ID for a complex type. It's great because we can do it in the browser. It's a very low-code, no-code approach. But again, if you try and map that up to the identity, that gives you a very negative use case. We can also use nested API calls. As I've mentioned before, and as we'll touch on a little later here, there we go. We can do this with calling, job 1, department 3, company 1. So this is great because it all, again, works in the browser. We don't really, not the browser. We can do this with a rule. We can go through, we can get them. It is a relatively it's a no-code approach. They're nested, it's natural within the web services source, and it directly maps the accounts and values. You can pull, job title, you can get all of your hybrid data. The bad here, as I mentioned before, you can get, 10,000 people, 250 a page, that's 40 API calls, and for every extra endpoint, you're now adding 10,000 more. For 3 endpoints, that's a 25,000% increase in the number of APIs. That's not free, that's not cheap, that is very, very time consuming. Oh, sorry, there we go. Sorry, I hit the wrong button there. So again, I will touch on this in a moment here, but effectively this is your flow. You have your aggregation with a child based on the ID of the user to get your job title, get your department name, and keep going. It's simple, you can do it directly in the UI, but it's not the most efficient. So again, I'm going to demo these in a short while here, but we can do what I always call the Goldfish style web service after operation rule. We get a page of users, we call the job API, we build a lookup table effectively in runtime in memory, and directly reference that every page, which is great. It brings us from 10,000 down to 160 API calls. But why are we getting the same data twice? So that leads to then the preferred choice here, the I know this one, I have that in memory version of the API, which uses something that is called transient values within the after operation rule. Essentially, it is runtime memory. We've created a value, we have stored it, and it will survive from the start of the aggregation until the end of the aggregation. So again, I cannot always trust that HR has told us when the data has changed, but I don't need to. In my 5-minute aggregation, I can assume that the values I have when I look up what those numbers are will be correct and usable as we come through, which through memory, again, I'm going to look it up, I'm going to store it, and then I'm going to reference it. That can bring me down to one lookup for each. It is the most efficient way we can do this, and I'm going to actually jump into a coding demo here after a quick summary. Sorry, my apologies. But really, at the end, we want data, we need good data, we want usable data, and we have to get it. So there is a breakdown on the right here, but effectively we can turn 30+ thousand API calls into one for each set of data. So that is where I'm going to hopefully have a switch here, and we are going to try and do this live. So really quickly here then, the connected parent-child endpoint, very simply, we get our accounts, and then we have a child aggregation where we call the child with the response job ID. Off the job ID, all we get is a job ID job title, and we're overloading that directly onto the endpoint. So I have a case here I've already run. We're just going to quickly touch on this, but paginating through and calling each endpoint directly takes us, last time I ran this, just the interest of time, 3 minutes isn't terrible for 1,000 records, but it took a full 3 minutes, and it made several thousand API calls to fetch that data. So as a skeleton here, before I dig into what we're going to be, wrong one, before I actually dig into all of the code, just as a skeleton, one thing I will touch on, please, if you're making code that has logs, make a consistent log prefix that you can use for filtering your logs. We get through. So just a quick skeleton before I dig in. We're going to have to build the HTTP statuses. A 200 is a good value. We're going to pull the headers and the authentication directly off of the web service endpoint. You never need to hard code a password. You never should hard code a password. That is a bad idea. We're going to pull the URLs and everything we need off of the endpoint itself. And then, well, here's where we'll look up our data. We'll get to that in a moment. But now, if we have a response, if we've gotten a page worth of users, we're going to iterate over them, and for each user, do stuff. So in my case here, because I am pulling a map off of that response, I'm just going to quickly, we'll use them later, reference the job ID, company ID, department ID of your user. And then, a few little kind of housekeeping items, we're going to stick those on a return object, stick those into process data, return that. So we are effectively using and throwing out the response from the endpoint itself, building our own response, and manipulating that data as we see fit. So this is where we will hit the point of actually looking up data. So we need to have, let's do job codes first, I believe. Job code map. Make a new hash map. So we're going to end up stuffing values into that value there. Personal preference when I am doing these the map projects or doing extra lookups, I will try and throw these into a try catch. Again, just to try and make sure that we are able to do what we need, not capped. There we go. Just so that we actually do individually catch these. So now that we have that, we have to make a URL. Jobs. So for each one here, we're building the URL we need to call, and then, that should be an uppercase S for string. Okay. There we go. So string. Because of the web service operation, we can directly call the REST client. Nope, spelling is terrible. And there is an execute function for all of the optional endpoints. In this case, I'm going to execute a get. So this will take the headers, the authentication, everything from the endpoint. Again, all I'm doing is telling it to call. I'm not actually using anything there. We need to tell it to call the jobs URL. We're going to tell it to use the header we defined earlier, which is just the request endpoint header. And we're going to accept the allowed statuses. So that will make an HTTP GET and get our values. We're going to need a JSON array to parse that. Equals. So we're going to convert that string response into an array of JSON. There we go. And then, equals 0, we're going to make an iterator. That is a semicolon in this case, not a comma. JSON array dot length. So we're going to iterate over that. Let's build our values. JSON object. I'm going to pull that out of the array by its value, by I. Oh, not get, sorry, that's not there. Dot get JSON object. There we go. So that should now give us an array, and I'll touch on the data in a moment here, but that should now get us a specific job, and I'm going to have a problem with that if I don't fix it. That will be a typo I will not find. So that's an object, not an object. There we go. So the job ID will be from our job JSON object. String. And it's keyed. I happen to know just from the data, this may not be the case for your implementation, but I happen to know that that is keyed by ID because I made that API. We're going to duplicate that line once, just because, again, I'm a little bit lazy. Our job title will be off of here with the key title. And then, because I'm going to make that map, that would be outside that. Job code map. We're going to actually put in our value. We'll reference this later, but this will be job code, job ID. So we have effectively here done nothing more than made an array of ID and title combinations. So we're going to look those up later. Oh, actually, we'll do that right now. So we still have a couple more APIs we can implement here, but that will now call the jobs API, get all of your APIs, look them all up and pull the ID to the value, and store, or temporarily here, we now have job code map with an ID title. So while we're iterating through our actual objects, let's add those. So, oh, that goes this way. There we go. I am going to be a little bit careful here, but we have that object. So if the job code map contains key, that would be the job ID we just pulled. So if Steven's job ID exists in the map, then we are going to add that to our employee entry. So this is not natively on the JSON pathed out value. The endpoint has given us first name, last name, email, job ID. So let's add then to our employee entry with the key of job title. That would be from the job code map dot get job ID. It goes over here. And we will, in the interest of time here, I'm not going to run what this is right now. I'm actually going to pivot a little bit to another version of this code that has a few others. I'll walk through it very quickly here. Let me just copy this. I go the wrong way every time. There we go. So I've done this a couple of times here. I just happen to know, in the interest of time, this one works. But we are doing exactly this. We are getting job codes based on what we have, building our map, doing the exact same thing. Nothing is new here. There's really no hand waving. We're calling company, getting your company, doing the same thing for a company map, doing the same thing for a department. And then I'm just doing this a third time. I am throwing in job title, company name, department name. And that's it. So rather than having thousands of API calls that run through, we are going to try and use a rule and paginate through here. I'm going to, what you see in the background here is just the API log from the server that is running this. So rather than showing all of them, we have pagination, we have our data. Let's see if this guy works, because I know that one's mapped. So that should in a moment. There we go. So we can see in the logs there, it's calling each page of data, calling job, calling company, calling department, and fetching through. So directly, I'm just going to try and find the right user here. On this source, natively, we have overridden the values that we had. And that was dev days 2. Oh, wrong source. They changed things on me. There we go. So on the raw source, I have not had to call anything an entitlement. Everything can be pulled directly up to the tenant, and we have now directly. He doesn't happen to have the company name, department name don't actually exist on this specific user. I picked the wrong one. But hey, he builds sandcastles for fun. We've overloaded the endpoint with his job title and stuffed it on there. But we can do better. So we're calling jobs, we're calling the company, we're calling department every time. Why don't we keep going and let's see what we can do about storing that value? So what that means is there's a couple changes we need to make. I'm going to do those raw here. So before we process anything, we are going to find our trend. There we go. Okay, so as we're grabbing our various items, we're going to pull a map from the application storage. So we're going to cast it as a map because application storage can do anything. Transient values. Okay, so we've pulled now a value from the tenant as transient values. Let's see if we need to do this. So if we have value, I mean, there's no point in doing this if we don't want to skip things. So we're going to throw a catch around here. If the transient value field is null, we're going to then do our lookups. I've killed that one. So before we do anything here, we need our extra closing. And then as we run through, so we're still going to do all of the exact same lookups we've been doing. But as we finish each one, so again, for job code here, outside my for loop, but still inside my try catch, because that's just where I prefer to put them. Transient values dot put. Oh, that's going to be a typo. I'm just going to copy the map name. So I'm going to put under the key of the job code lookup map, I'm just going to stuff in the actual job code lookup map. So now I'm storing the values I've looked up. Let's do that in about 3 more places. Actually, I think this is the only line I need. So we're just going to copy that guy. We'll do this in the other 2 endpoints with the other 2 map names. And you can do this for multiple, but with the try-catch blocks, if there's an error on company, it's not going to break the entire aggregation. All it's going to do is not feed me the company value. So there we go. Do the same thing here. And then after we've called our last API, there is one more step that we need. So we pulled a copy of transient values. We pulled a copy. We're setting values into it. But what we actually need here is the application set attribute. transient values, transient values. So we're going to actually now stuff that directly into storage, which is wonderful, which then means let's throw a little further down here as we start iterating, processing through. I'm not sure why this one's required, but one interesting trick here, if you're doing this, I would definitely recommend it. As you are processing the transient values, once you get to the point where you want to start iterating your actual items, transient, look it up again from memory. I can honestly say I'm not sure why it is easier to use and make happen, but I have had great success with looking up the transient value directly again when you start trying to use it. Get attribute value. So we're going to look up transient values. There we go. One more. Now we're iterating. We have our initial values. An interesting one here in the event that you are trying to take care for the null cases is, I mean, there is definitely a chance that your map, your transient values, will not actually have your value. If something goes wrong or if your API is relatively unstable, I would definitely recommend throwing the values directly within another lookup or another if statement. So if my transient values actually have a job code lookup map, then we're going to use the job code lookup map. But what is the job code lookup map? We have to do that one as well. So we'll grab that as well. Job code lookup map as a hash map. Job code lookup map. Okay, so if it has the key, build the hash map. Oh, there we go. Then pull, if it has the job ID, pull the title, stick the title onto your endpoint, onto your entry. We will do that for each of these endpoints. So pardon me while I copy a couple of things quickly here. And an extra an extra closing brace. This is actually going to be company lookup map for this one. So paste, 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 and one more time. There we go. We will fix. I will be providing the code for this later on as well, so that will hopefully help with getting anything else useful here. But our department map is the one we're looking for, so we'll pull that value from memory again. The department name, that's all there. And that really is all we should need. So if I can take all of this, we will escape our string. And I'm just going to off screen here stick this into my rule. It goes there, save. Let's see what it does. So I have this rule that we were working on here skeletonized out already on my endpoint. So we're going to come back to the source. And this happens to be another case. For the amount of presentations I've been doing on this, that'll come up to number 3. Why is that not responding? I'm going to take a quick second here and make sure I can actually test this. Okay, I turn off the API when I'm not using it, so that is fine and dandy. Let's see if our code, which I will unescape here, let's see if that actually works for us. So we'll come back to our server, make a break so we visually can see the difference, and let's run an aggregation and see what happens. And as you can see here flowing through, we called page 1, we called jobs, we called company, we called departments, we paginated through the rest of the endpoints, and rather than making, 10,000 or 100,000 calls, we successfully got, 7 calls, whatever, the 10 for paging plus 13, 14 calls. We got all the same data, and it took us now, rather than the 3 minutes, this took 3 seconds to call 9 APIs. So in reference here, just for the last few moments, when we tried this with the direct initial instance, when we were using the parent-child relationship, I just want to show you how terrible that looks. So if I try this on the one with a parent-child relationship, oh, it's going to keep running if I hit enter. This this is terrible. So this is now getting a page of results, and then for every single user, directly calling and fetching job 1, job 2, job 3. We're calling this 1,000 times. It's iterating. It's taking a significant length of time. And this can hammer your API. This can break everything. This is a headache waiting to happen, and it does not scale well. So again, I will be providing the source code for this, for the web service rules that I've written. Each step, I'll be providing those probably next week to the developer community. It looks like I finished a few minutes early here, but really thank you everybody for attending developer days and for joining this and for being interested in the neat things we've been figuring out how to do. I'm hoping to see you folks next year.